All right, on to lecture 6, which deals with California's climate. When you look at the climate of any region of the world, that is one of the primary factors that really dictates what kind of plants and therefore what kind of animals can live in an area. Of course, climate, is always a factor in determining, even things like geology to a degree. So, a lot of times people confuse a couple of words, the words climate and weather, or I should say maybe they use them as if they're the same thing. So let's just make sure we're all clear on what exactly climate is. When you look at the overall combination of different things that happen around us every day, like temperature, and the range of temperature during a year, how cold it gets in the winter or how warm it gets in the summer. Then you add on the effects of the amount and timing of precipitation. Does most of it fall as rain? Does most of it fall as snow? Does precipitation fall daily or year-round, or is it very seasonal? Winds as well. Being in the northern Sacramento Valley, we are heavily influenced by winds. Not only the way the storms come in or high pressure, but the daily winds that go up and down the mountains because we're in a valley surrounded by mountains. Things like humidity, etc. All of those kinds of factors ultimately determine what the climate is of an area. And again, it's the range of those factors from day to day and from season to season. So any given region, when you look at the compilation of these factors and other things too, like topography, are you, again, maybe in a valley surrounded by mountains or whatever, that adds in there as well. So what the hail is weather? Again, I said weather and climate are often kind of intermixed as far as people thinking they're the same thing. The main difference, the primary difference, is that weather is the daily variation in things like temperature and precipitation and winds and humidity. So today it happens to be windy, and I guess you'd throw in things like there's smoke in the air, which would have actually been pretty normal here in Redding during the summertime. We would have always had fires going on around us even before there were as many humans here. So today it's going to be 107 degrees, no precipitation in the forecast, winds out of the north, low humidity, which can all relate to the fact that this is an area that's prone to having fires, and those factors all play a big role in fire. So you could even throw that in the mix as a as a daily factor that affects an area. So again, weather is what happens daily. Climate is the big picture, the year-round variation in those things. And so then, of course, when you watch the weather and the guy or girl standing up there is telling you what the weather is going to be like today, of course, they're meteorologists, and that is what the study of climate and weather entails, meteorology. Again, another very interesting aspect of natural sciences. Again, even as a wildlife biologist, a forester, soil scientist, whatever, you still do have to understand the role of daily weather and climate on the area that you're studying or managing. Of course, in some places, being a meteorologist is a pretty easy job. Normally in Redding in the summer, you come on and say, oh, it's going to be hotter than hell today and sunny. You're pretty much going to be right 99.9% of the time. And then, of course, when they get it wrong, they can always blame it on, that it's not really 100% predictable. Of course, they base all their model forecasts on computer models. So those models are only as good as the data, of course, that gets put into them. But Some areas are fairly predictable, like again, we are here in the summer, pretty predictable weather. Other areas, a lot less predictable. So what creates these daily weather variations and the long-term climate of a given area? Again, there are a lot of different variables that play into that. First, of course, just the fact that the Earth rotates, and it at different times might tilt towards the sun. So for us in the northern hemisphere, this time of the year, the northern hemisphere is tilted a little bit more towards the sun, so we get a little more direct angle where the sun is hitting us. In the winter, then obviously we're tilted away from the sun a bit, so the southern hemisphere gets summer, we get winter. But that heating, and it's different from the equator where it's more consistent. To the farther north or south you get, where the daily heating patterns are different. And because of that uneven heating, not the whole Earth doesn't get the same level of sun all the time, that creates things like the winds that drive the weather patterns and the climate in the Earth. So these uneven heating patterns, where you get the warm air as the surface warms up from the sun, the air wants to rise, and that then draws the cooler air from up higher down. As the air rises, it cools and sinks again. The warm air gets near the surface, it warms up, or I should say the cool air gets near the surface and then warms up and rises. So that constant kind of churning is what creates the winds. And then of course those winds, because they're cycling from the surface, and it could be over the ocean or over land, and because those wind patterns are then carrying that water vapor from the Earth's surface up, and then also obviously from the atmosphere down as precipitation, snow, rain, whatever. Basically it's that uneven heating and the winds and all that drive the water cycle. There are a number of cycles that are relevant to understanding the ecology of an area, how things like carbon or nitrogen move through the environment. But certainly maybe the most important one, at least in relation to weather, is the water cycle. And so again, because of that uneven heating and the warm air rising and cooling, the cool air heavier, sinking, and then warming as it reaches the surface, creates these again these movements. And so you get the evaporation off waterways because of this heating. Water molecules get excited and they separate and form a gas. That evaporation, whether it's from an ocean or from plants or animals like us that sweat in the summer, that water vapor rises, which again the water vapor then ends up condensing as it goes up because it gets cooler. So the cool air can't hold as much moisture. When enough water molecules kind of bump together and bond and get too heavy to stay up as a gas any longer, then they fall back to the Earth as some form of precipitation. Again, whether that's snow or rain or whatever. That water then, some of it of course does fall as snow, and it might even be stored long term at higher elevations, and that really is what feeds all the water to our valley here in Northern California. But then of course some of it lands on the ground, provides water, accessible water for the plants and for animals via the streams, lakes, rivers. But then water also is going to infiltrate into the soil, where it accumulates at some depth below the surface, and then eventually that groundwater continues to move, and eventually is going to end up filtering into a nearby lake, stream, river, or ocean, where then we get to start that cycle all over again. So having a basic understanding of the water cycle is again really important for us to understand anything else about the natural world around us. So something to consider, we look at areas in the tropics close to the equator, and we have tropical rainforests where they may get 100 or more inches of rain every year, sometimes as much as 200 inches of rain. And basically it rains every day in the tropics. So why does that happen? And why doesn't it happen in Redding, for example? Well, again, near the equator, the sun's always hitting the Earth pretty directly. Whether or not the Earth is tilted towards or away from the sun at any given time, the sun's rays are more direct right at the equator. So you get lots of heating. It's not that it's always the hottest place on the planet, but you get consistent heating. So you get consistent amounts of warm air that rise. And therefore, that warm air rises up, starts cooling down, and circles back towards the equator from both the north and the south, partly because of the rotation of the Earth. But that warm air rises, cools, cycles back towards the equator, and of course, again, when the warm air starts cooling, as it goes up, it can't hold as much moisture, so that moisture has to fall back as rain. So again, because of that constant sort of heating, you are constantly driving the process that generates rain. And because of the rotation of the Earth, that rising air circles back from both the north and the south towards the equator, creating basically that daily rain. Plus, when you're in a tropical jungle, because all the plants are transpiring, losing moisture, even because of how thick the canopies are, the moisture will leave the plants and kind of rise up. And then because of all of the vegetation and how humid it is, sometimes that moisture condenses again and drips back down through the rainforest. So it's almost as if it creates its own rain, sort of, because again you get the moisture being kind of trapped in the dense forest and then condensing again as it rises and dripping back to the earth. And so basically the area between the tropics of Capricorn and Cancer, about 23.5 degrees north and south, that area north and south of the equator is considered the zone of daily rain, because again it gets the most direct heating. North and south of those areas we get the zones of evaporation. Again, the warm air rises, cools, descends, the air is pulled towards the tropics, and this basically draws the moisture from the surface, taking it towards the tropics. So this is what's feeding the tropics, but therefore it's also what's pulling the moisture away from those areas around 30 degrees north and south of the equator. And so this creates our bands of desert that we have around the The idea that again, you're going to have clockwise rotation in the northern hemisphere and counter in the southern hemisphere. Again, because of the Earth's rotation, it sends the ocean currents going in those directions. And then, of course, again, you've got the water near the equator is going to be warmer, just like we were talking about with the air near the equator. And then, of course, that travels northward along the edge of the continent, hits the colder Arctic air, which then travels southward along the edge of the continent and creates these global water currents. And this image does a good job of showing those warm and cold currents, right? You got the equator here, again, just to put it in perspective. You get the warmer equatorial current and warmer water, and then again, as it kind of flows northward, it starts to cool, cooler water up here, and then that cooler water flows again clockwise along the next continent that it hits. And of course, as it goes south, it encounters that warm water again, and so it warms it up and continues the cycle, and we see the same sort of cycle. Now again, notice it's going this direction in the northern hemisphere. Same thing in the Pacific, it's going clockwise. Southern hemisphere, we see it going the other way. Same thing for these, this side of the globe. So again, you notice the warm water near the equator. As it meets the Antarctic waters, it cools down. The water actually sinks as well, and then starts rising as it comes back north. Again, hits the warmer water, which warms it up. And so it's again the differential heating of the Earth. More heat near the equator, less heat away from it, drives the winds that go up and down as they cool and warm up. And then that, along with the rotation of the Earth, drives all of these ocean currents. So there is one generalization that we can look at, and that's the fact that water on the east coast of a given continent tends to be warmer, and water on the west coast of any continent tends to be cooler. And again, that's certainly the case in North America. We have much cooler water in the Pacific than we do over on the Atlantic side. And so, of course, in the big picture, then that influences the climates of those areas. So the wind currents are following the ocean currents, which again means in North America they're going clockwise. And so during the winter time, especially us in California, most of our winter storms are coming from towards Alaska, the Pacific Northwest, and the Gulf of Alaska, and they track southeasterly towards California. But then you also see that individual storm cells will actually kind of spin counterclockwise. So again, we see northern hemisphere, the typical rotation of a hurricane. And again, remember everything else we were talking about, the ocean currents are going clockwise, right? This ocean current out in the Atlantic is going clockwise, but then these storm systems come in and are rotating the opposite direction. And then, of course, it's the opposite of that in the southern hemisphere. So again, one of the primary factors that drive our climate in California from Baja all the way up through to Alaska are the weather patterns up in the Gulf of Alaska. And so again, we get this general flow of these small currents up here, which again you can get them kind of flowing the opposite way of the major currents. Remember, again, clockwise in the northern hemisphere. But because of the combination of wind and currents, you actually can get smaller areas that will go the opposite direction. And so you get the downwelling of the water as it gets near the coast. You get the upwelling as it comes south towards us. So water from deep coming up near the surface, so the colder water from deep coming near the surface, warming up a bit, and again having the influence on this whole area along the coast here because of that upwelling, keeping again this entire area, even up to Alaska for that matter, but this entire area, the west coast of North America, having a moderated climate because of that. And so then because of all that happening out in the ocean, the air, of course, picks up moisture from the ocean as it's evaporating. And then as that moisture is carried over land, it'll start dropping it as the air cools down. And again, the moisture condenses, then it's going to tend to drop that moisture on the nearby land. If we look at a precipitation map across California, a couple things that stand out are that the areas around Del Norte and Humboldt County are areas that typically get quite a lot of precipitation. The northern Cascade region, right, kind of Lassen County and some of these other northern counties get 60, 70 inches of precipitation a year. Now again, some of that's going to be, or a fair amount of it, is actually going to be snow as well in the winter time. But then notice how, as we look at the valley, and especially the San Joaquin Valley, we're talking 0 to 10 inches of rain, and maybe up to 15 or 20, and then as again you can see it kind of increases as you go north. This big area down here where we grow so many fruits and veggies is basically a desert. Any area that gets less than 10 inches of rainfall annually is the definition of what a desert is. You know, you might think obviously of areas like Death Valley, the Mojave, the Colorado deserts, right? Those are all obviously called deserts, but most of the valley south of Sacramento is also a desert. The only reason we can grow so much food there is, what do we have right above it? We have the mountains, the Sierra Nevada, and we get, you know, again, anywhere from 30, 40 to 60 or 70 inches of rain, and most importantly, a lot of that is snow. So that snow slowly melts as the spring and summer continue on. Though that water melts, fills the streams that flow down into the valley, where then that water can be harvested. But you look at how much of California is in bands of you know, areas where you get typically less than 20 inches of rain. That is a huge part of the state that's in that category of almost a desert, or is truly a desert. And then of course, where do the vast majority of the people live? Down in this part of the state, the part of the state that's least equipped to be able to provide water. So a lot of the water does come from other parts of the state, and other states, of course. I mentioned topography as well back when we were talking about what influences climate. And so in California, because we have the ocean, we have a kind of a long, narrow state, we have the ocean, we have coastal mountain ranges, we've got the valley, then we've got another set of mountain ranges. We get a lot of rain shadow effect happening in California. So anytime, so for example, if this were the coastal mountain range in California, we got the ocean over here. Again, we got climates that kind of moderated because the ocean's, you know, not too hot, not too cold. So that warm, moist air that picked up all of that moisture from the ocean now starts to go inland. It's warmer air because it's down near the surface. It starts to rise because it's being pushed up over the mountain. Of course, it gets cooler the higher in altitude you get. So as this warm, moist air is going up the mountain, cooling, it can't hold as much water vapor, so that water starts to fall. And so you get this side of the mountain gets lots of moisture, so you have nice lush vegetation. By the time this weather pattern has gotten up over the mountain, it's been pretty much dried of the moisture. And so then, because all the moisture is gone before, it gets over the other side of the mountain, continues on, and basically now you have really dry air. You get all the evaporation from, you know, the compression of the warm air pushing down, kind of squeezing moisture out of the atmosphere. And so then you get these more deserty climates. And we've got that both in the coastal and the Sierra Nevada. On the drier side of the coastal range, it's not deserty. It still gets a fair amount of moisture because of how close it is to the ocean. So you get different types of vegetation, but not cactus, for example. But then as you get up over the Sierra Nevada mountain, which is much higher, again, because the weather patterns have much higher to go to get over the mountain, more of that moisture is squeezed out of the clouds, which makes an even more pronounced rain shadow on the eastern side of the Sierra, where again we have all of our deserts in California, and then the Great Basin that extends for hundreds of miles on. Because of valleys, or specifically the Great Central Valley being surrounded by both, you know, lower coastal mountains and higher Sierra Nevada, we also get what's called temperature inversions. we have the cool air, flowing down from the higher elevation, and the warm air sort of getting trapped. So it actually gets trapped and doesn't have the ability to rise, which normally, again, it would. So because you have such a downforce of cool air and the warm air tries to rise, it creates this fog belt. In the Central Valley, we always called it Tule fog. Just, literally can't see 2 feet in front of your headlights, even if it's not completely dark outside. And so you're basically trapping air, and in one case it maybe only creates fog, a band of moisture that gets so thick it's hard to see. But then the other big problem is if you're in a basin that has a lot of people in it, a lot of cars, in other words, a lot of sources of pollution, you can actually get that pollution trapped under that inversion layer and creating these winter smog inversions. So it's not only that you can't see very well, but also that pollution that would normally kind of move away from you gets trapped down near the elevation of where we are. So you have a lot of those bad air days. Happens in the Sacramento Valley as well, but not nearly as obvious as in the San Joaquin and certainly in the LA basin. So more about the effects of the rain shadow. Again, what that does is make the west side of the mountain ranges wetter, the west side of the coastal range, the west side of the Sierra Nevada. Look at places like Lake Tahoe. A lot of snowfall every year. Even on the northern extent of the Sierra Nevada, Lassen. This year, of course, we were above average rainfall, but parts of Lassen got 30 feet of snow. Took them till late in July to be able to plow the road through Lassen because of all the snow. So obviously that makes for areas where you get good skiing. But then, of course, the other side of that is when you get to the east side of these mountain ranges, then most of that moisture has been squeezed out of the clouds. And so now you get the dry area that basically is desert. Can either look literally desolated like this area, or certainly deserts can have plant and animal life, but they're still dry. They still are never going to be as abundant with life as the other sides of the mountain ranges. And so again, in California, because we have a long, narrow state, we have a huge influence of the maritime climate. Again, the climate as influenced by the fact that we're so close to the ocean. And again, as I mentioned, the ocean itself has very little variation in its temperature. It's such a big body of water. Water itself serves as a buffer. It takes longer to heat water than it does to heat air, so that ocean temperature stays fairly constant day to day. And so therefore, because the water is a relatively constant temperature, it moderates the temperature on the land as well, so you don't have nearly as wide swings from night to day the closer you are to the coast. And then, of course, because of the moisture that's constantly being brought in by the prevailing winds that blow from the ocean towards the land, you get the fog belt area there as well. Areas along the coast where you could have 300 days a year, if not more, where you have fog. Sometimes the fog lifts as the day warms up. Sometimes, especially certain times of the year, that fog belt may stay there. But what that fog belt does is again influences the vegetation along the coast. You get plants that maybe they don't get as much rainfall, but because of the fog, you constantly get this drip. And so trees like the redwoods thrive in that area. They get enough rainfall, but they also get, again, a lot of evapotranspiration that falls back, and all of the fog that condenses on the plants and then drips back down to the ground. So in California, this type of climate is called Mediterranean because of the influence that the proximity to the ocean has on our climate. Furthermore, things that define a Mediterranean climate are the fact that we have a distinct wet season and a distinct dry season. I grew up in Wisconsin, where we had rain off and on all summer and snow off and on all winter. So basically precipitation year-round. As you know from living in California, especially in the valley, that we have a wet season that extends from maybe October or November through maybe May. It's not impossible to get a little bit of rain here and there during the summer months, but it's certainly not typical. More likely in the mountain because of the movement of air, again, up the mountain and condensation. But Mediterranean climates around the planet, and again, California isn't the only place that has a Mediterranean climate. As you might guess, it was originally named because of the climates that places around the Mediterranean Sea have. We also look at seasonality, how the weather patterns change over the course of a year. And again, that can be influenced by whether you're on the coast, where again the climate's going to be moderated, or how far inland you are, where you have less impact of the ocean, and so you can have colder winters. The latitude, of course, we already talked about how near the equator, because of the more consistent heating, there basically are no seasons near the equator, because it's always getting the same amount of sunlight. Almost always 12-hour days, 12-hour nights, similar temperatures year-round. But then, of course, the farther north and south you get from the equator, then you start having the different seasons because of, again, the ocean currents, the wind currents, and how those change the heating and cooling of the planet. Of course, elevation as well as latitude. Elevation's kind of the same effect as latitude, but more locally. So the farther north you go, the farther north in latitude you go, generally the cooler the climate is, right? We all know that. But it's also the same with elevation. The higher up into the mountains you go, the cooler it tends to be. More precipitation falls as snow in these cooler areas. So that's a little overview of weather and climate, and how climate affects different aspects of the environment, again, including where life exists. All of that variation in climates and affected by latitude, altitude, topography, all of those things affect the ecology of an area. And so the next topic that we're going to get into is basics of ecology. So just kind of to wrap this up, any type of career you choose that deals with the environment. So again, anything you think of as being an outdoor job where you're working with fish or plants or animals or soil or water, you have to understand a little bit of a lot of different things in order to be able to be good at doing those kinds of jobs. And so whether or not you have an interest in a career that deals with these kinds of things, even as just people that live in this world, this stuff is around us all the time. Sometimes we don't pay attention to it, sometimes we go looking for it. And so even if this isn't something you may decide you want to do as a career, there's probably nothing more important that humans should do than pay attention to the world around us. Obviously, family, we have to work, but we also should pay attention to the world around us. It's all of our responsibility to kind of keep track of the planet And if we notice things that aren't looking good, it really should be our obligation to help point that out. So again, up next we will be talking about the basics of ecology.